Android is an event-oriented programming environment. Your Java code is typically executed in reaction to events that are generated as a result of user actions or by the operating system or app framework. To track these events in your programming and see what's going on the device and in your apps, we use a tool called Logcat that's built into the Android SDK and into Android Studio. To demonstrate Logcat, I'm using a project named Logcat, and I've opened the main activity class. I'm also running a virtual device that currently isn't running any apps. To show the basics of Logcat, I'll come back to Android Studio, and I'll open the Android window by clicking Android in the lower left corner of the screen. Then I'll expand the size of this window. I'll click the gear icon in the top right and choose floating mode, and then drag to expand the size of the window. Even without any apps running, the device is sending a lot of messages to the Logcat output. These messages, typically without an app running, are coming from the operating system or the application framework. You can filter the messages very easily by clicking into this text box and typing some string. For example, if I type Android runtime, I'll get messages that are coming from the runtime itself, from the ARC runtime or from Dalvik, depending on which version of Android you're running. You can send custom messages to the Logcat output by using a class named log in your Java code. So I'm going to shrink down this window and come back to my main activity class. My main activity class has 3 methods. Each of them is being executed in reaction to some event. The onCreate method is executed when an activity is created in memory. onCreateOptions menu is called when the framework tries to create the menu items that are displayed in the activity. And onOptionsItemSelected is called when the user chooses one of those menu items. I'll start in the onCreate method. I'll type the name of the class that we use to send a message to Logcat. It's just named log. Android Studio shows 2 available classes named log, and I'll choose the one from the package android.util. When I select the class, that adds a required import statement at the top of the code. Now, when I press the dot character, I see a whole bunch of available methods. There are 5 key methods that have a single character as their name. D stands for debug, I for info, E for error, W for warning, and V for verbose. These are called logging levels. Error is the most critical sort of logging message, and verbose is the least critical. You choose a logging level depending on how you want to filter it when you look at your Logcat output. Now, I'm going to choose something in the middle. I'll choose the D method for debug. It'll give us an opportunity to see how Logcat messages are filtered. Each of these methods has 2 versions, one with 2 strings and one with 2 strings and a throwable object. I'm going to use the simpler method. The first string is called the logging tag, and it's just a way of filtering your Logcat messages. One common practice is to use the name of the current activity, so I can look at all the messages from a particular activity. So I'll use that as a string, the name of the class, and then I'll type in the name of the current method, onCreate, as the message I want to send. And let's test just that much code. I'll click the Run button, and if you're prompted to choose a device, choose the virtual or physical device that you have connected to Android Studio. After the app is displayed, go back to Android Studio and change the filtering string to the name of the activity, main activity. I'm showing 3 different versions of the onCreate message, and that's because I'd run this code previously on this same version of Android Studio. But I'll clear the messages by right-clicking and choosing Clear All. Then I'll come back to my virtual device. I'll exit the app by clicking the device's back button. Then I'll go to my app list, and I'll locate the app labeled Root Catalog, and I'll run it again, and I see that the message is generated again. And this is a clue to how this event works. The onCreate event is dispatched every time the activity is created in memory. And when you exit the app by touching the back button on the device, that destroys the activity, and when you relaunch the app, that recreates its main activity. Next, I'll add a bit more code. I'll go back to the home screen on the device, then come back to Android Studio and shrink down that window. Here are my other two events I can react to: onCreate Options menu and onOptions item selected. I'm going to select and copy this one line of code that starts with log.d, and I'll paste it here right at the beginning of each of these methods. And then for the two versions I pasted in, I'll copy and paste the name of the method as the message I want to output. And then I'll run the app again. What I see on the right is that the onCreate method is executed, and then onCreate Options menu is executed. So the menu is being built as the activity comes to the screen. And that's why the menu item shows up here when I touch the menu icon. Now, when I choose Settings, I see the third message, because that results in executing the method onOptions item selected. So you can add as many logging messages as you want. Here are some other ways of filtering, though. Notice I'm filtering both on the tag, main activity, and on the app package. You can create your own custom filters. To do that, pull down the menu over here and choose Edit Filter Configuration. And then, for example, you could add your own log tag or choose your own logging level, and then name your filter. So I'll call this filter Debug Main, and I'll add the log tag Main Activity, and I'll keep the package name, but I'll set my logging level to Debug, and click OK. And now I'm only seeing those messages. If I want to see more messages, I can click No Filters, and I see everything. And then I can once again choose the filter I just created, and I'll be narrowing down the output again. Finally, I'll show you one other place where the Logcat output can be seen. I'll go to the menu and choose Tools, Android Device Monitor. When you choose that option, you'll see that your connected devices list in the Android DDMS window goes blank. But then when the device monitor opens, you'll see the output here. Here's my device again, and when I select the device in the device's view, I see my Logcat output here. This is the old Eclipse interface for Logcat. Android developers who are accustomed to working in Eclipse might choose to use this version of the Logcat output. Developers who are new to Android development should probably get started with the new version of the Logcat output that's a part of the new interface of Android Studio. So throughout this course, and in my ongoing development work, I'll be using Logcat extensively to find out what's going on at runtime in the app and on the device. Once you know how to trace an event, how to send a message to the Logcat view, you can then start adding event handling code to your app. There are a couple of ways of doing this. I'm going to describe how to add an event handler that's registered in an XML layout file that results in calling some Java code in your activity class. I'm working in the project Layout Events that already has some logging code in the main activity class. I'm going to jump to the main activity class's layout file, activitymain.xml, and then look at the layout file in text mode. I'll double-click the tab up here to look at the code in full screen. I'll scroll down to the bottom to where I've registered a button control. The button control has a text attribute of register, that's the text it displays on the front, and it aligns itself to the bottom and right corner of the activity. In design mode, the register button shows up down here. In text mode, I'm going to add an onClick attribute. This is an attribute like any other, but instead of affecting the design of the button, it controls what happens when the user touches or clicks on the button. Next, I'll assign a method name. This will be the name of a method that I want to call that I'll need to create in my main activity class. And I'll name the method Register Click Handler. Now, I could go over to main activity, the Java class, and create the method from scratch, but Android Studio makes it very easy to create the method stub. I'll use an intention action or a quick fix, holding down the Alt or Option menu and pressing Enter, and then I'll choose the action to create the method in the main activity class. That creates the method stub and takes me back to the Java class. Now I'll use some Logcat output. I'll type log.d. Once again, I'll use main activity as my logging tag, and then the name of the method that's being called, Register Click Handler. And I'll run this version of the app in my virtual device. Now, I've restored my Android DDMS view so that it's no longer floating. I did that by using the gear icon over here. But now I'm going to filter on the main activity tag. And then I'll clear my messages. And then I'll come back to my device and I'll click the register button. And there's the result. I see that I'm successfully dispatching the event and calling the event handler method. Let's go back to the code and look at the method again. Event handler methods that are executed as the result of an event that's dispatched from a view, that is, from an activity, or a button, or a text view, or some other visual component, always have the same method signature. They accept a single argument or parameter, an instance of a view, and they're always representing the object that generated the event itself. So from this code, I could cast this as a button, because I know that that's what generated the event, and find out what the button was doing at the time. So here's an example. I'll create an instance of the button class. I'll name it btn, and then I'll get the reference by referencing the view argument. And then I'll cast the view to button. Now, because this is a button object, I know it has a text property. And so now I'll extend the message by adding a colon after register click handler, and I'll append to that btn.getText, getting the text value from the face of the button. And I'll run the app again. When the DDMS window appears, I'll clear my output, go back to the device and click the button again, and this time I get the label from the button, the text value. Notice that I'm getting the value as it's registered in the strings.xml resources file and not as it's being displayed in the actual app on the device. That's all uppercase because it's affected by the themes and styles that are registered with the app. So that's a look at how you can handle events that are dispatched by views, by registering the events in your layout files and handling them with Java code. As I previously described, you can listen for certain events by registering them in XML layout files, but you can also register events and listen for them with pure Java code. I'm working in a version of my project named Java Events. In this version of the project, I don't have any attributes in the button declaration in the activity layout file that would register or run Java code. Instead, all I'm going to do in this version of the layout file is assign an ID attribute. By registering an ID, you can get the handle to the view, the component or widget, whatever you want to call it, and then set up listeners for the events that component will dispatch at runtime. To declare the ID in your layout file, start with @+ID/ and then register an ID. I'll name this object btn register. Now, in my main activity class, I can get a reference to that component as the activity starts up. You can typically do this in the onCreate method or in another method named onResume that we'll talk about later. I'll do this in the onCreate method that I already have. Just as I did previously, I'm going to get a reference to my button object. I'll declare a variable typed as button. I'll make sure that I've included the import statement for the button class up here. I'll name it btn, and I'll use the findViewById method to get the reference. I'll use the expression r.id and then btn register, the ID that I just created for that object. As always, when I call findViewById, I need to cast the return value to the appropriate class, and I'll use a quick fix or intention action to do that. Now I'm ready to create an event listener for the click event. I'll use this code, btn.setOnClickListener. This method takes an instance of a class called onClickListener. I'll start with new and then start typing the name of the class. When you start typing, make sure you're spelling it exactly right, and it is case sensitive in Android Studio. Once I find the class name, onClickListener, a member of the Android.View package, I'll select it, and Android Studio fills in the entire stub. I'm creating an anonymous object and implementing an interface all at the same time. So now any code that I write in the onClick method that was generated will be executed when the user touches or clicks the button. Just as I have previously, I'll use Logcat to register the event. I'll use main activity as the tag and then the name of the event as the message. And that's the finished code, and I'm ready to test. I'll run the app on my virtual device, and then once the app has reloaded and I see the DDMS window appear in the background, I'll clear the DDMS window output. Then I'll make the device visible and click the register button, and there's the result. I see the Logcat output register that the event was dispatched and it was handled with this Java code that I created. So these sorts of events that are generated by visual objects, by Android views, can be handled either in the XML layout file where the objects are declared, or can be handled in pure Java code. Different developers have different preferences about how they code event listeners, but both approaches are available to you when you're coding Android apps. Activities in Android go through a life cycle, a set of stages, as they appear and disappear on the device. Activities are grouped into tasks. Typically, the activities of a single app are all in the same task. For example, when you first open an app, its launch or main activity comes to the screen, and that activity is a part of a task, and if that activity then launches a second activity, the first activity goes to the back of the task, stored in an area known as the back stack, and the second activity is on top of the stack and is the only activity that's available and visible to the user. The Android framework works this way to preserve memory and other resources. If the user were then to press the device's back button, or the app finished the second activity, that would remove the second activity from the stack, and the first activity would come to the foreground. Now take a scenario where the user presses the home button on the device and then goes to a new application. That creates a second task, which has its own stack of activities. The user can then switch between tasks either by going through the launcher screen, that is by pressing the home button, and then relaunching the first task, or by going to the screen that lists all of the open tasks. Either way, all of these activities are still available as long as the device has adequate memory and resources, but only one activity is available at any given time. At any time, if the operating system detects a low memory condition, it can remove certain tasks and activities from memory, forcing them and their apps to be relaunched. Here are some of the rules around activity stacks. On a single device, only one activity is active at any given time. There can be more than one visible activity. For example, in a screen that's laid out with fragments, or on a device that can show more than one app at the same time, you can have multiple activities visible, each with their own layouts, but only one will be fully interactive at any given time. While that one activity is active, another activity can be the most recent or the last activity. If the user presses the back button or the active activity finishes, then the last activity can become active. Other activities that have been previously viewed are queued in the backstack as previous activities. And you can have as many activities in the backstack as are necessary for the functionality of an app. An activity can be in one of a number of different states. There are transient states, states that an activity goes through to get somewhere else, and resting states. If an activity is visible and interactive, it's said to be either active or resumed. That means it's at the top of the stack. It's visible, and the user can interact with it. An activity that's paused can be visible but without focus. So let's imagine an app where you have a list on the left and a detail screen on the right. If the user is scrolling the list, then the detail screen will be paused. But if the user is typing something into the detail screen, then the list will be paused. Both activities can't be active at the same time. An activity that's inactive has been completely removed from the activity stack and will need to be reinstantiated to be used again. Here's what the activity lifecycle looks like, and here are some tips about how you can program with it. There are 5 states that an activity goes through. As an activity comes to the screen, it goes through 3 states, and each of the states is associated with an event, and each event is associated with a method where you can add code. The activity first goes to the created state, and the method named onCreate is called by the framework. Then it goes to the started state, and a method named onStart is called. And then finally to the resumed state, when onResume is called. When it's in that resumed state, it's visible and interactive. Now, as the user closes down the activity by pressing the back button, the activity will go through 3 more events. It'll go through an onPause event on its way to the pause state, and then if it's going to become invisible, it'll go through the onStop event into the stopped state. And if it's completely removed from memory, it'll go through an onDestroyed event on its way to oblivion. There are a couple of other interesting event paths to know about. If an activity is in the stopped state and you want to get it to a resumed state, it'll go through 3 events: onRestart, onStart, and onResume. And if an activity is paused and it needs to get to resume, it'll just trigger an onResume event. The best way to get to know these events is to program with them. So throughout the rest of the course, I'll be adding bits of code to each of these event methods so we can see exactly when they're executed. As you've seen previously, when you create a brand new Android project, the main activity has an onCreate method already stubbed out, and that's where you typically set the content view, loading up the XML layout file to define the display for that activity. So, this is an example of adding Java code in a lifecycle event method, the onCreate method, which is reliably executed each time an activity comes to the screen. As a developer, you should get to know the lifecycle events and their associated methods, and follow the recommendations in the Android developer documentation for where to place particular bits of code. I'm now working in a version of my project named Lifecycle Events, and I'm going to add code to listen for all the different lifecycle events that happen as you start and stop an activity. The main activity class already has code to log the onCreate method. Now, I'm going to be logging a lot of events here, and I want to use the same logging tag each time, so I'm going to take this string, main activity, and refactor it as a constant. I'll select a string in one occurrence, you can choose any occurrence, and then go to the menu and choose refactor, refactor this. Then I'll extract a constant. And I'll name this new constant log_tag, and I'll replace all occurrences. When I press enter or return, all instances of the string main activity have been refactored as this new constant, log tag. Now I can reuse that constant as many times as I want to. Next, I'll add an event handler for the onStart event. I'll click below an existing method, and type onStart, and then choose the event method that's offered by Android Studio. Android Studio starts with a method stub that includes a call to the superclasses version of the same method. You should always call the superclasses version of any lifecycle method. So I'm going to keep that code there, and then I'll copy and paste my login code, and I'll change this version to output the name of the method, onStart. Then I'll do the same thing to create an event method for onResume. I'll type the beginning of the method name and then choose it, and then I'll paste in the login code, making sure to keep the version of the code that's calling the superclasses method, and I'll change the name of the method here, and now I'm ready to test. I'll run the app in my virtual device. Now, to see just my lifecycle events, I'll filter by going to the text box in the Android DDMS window and typing d/main activity. Then I'm going to expand the size of the logging window and clear it. Then I'll go back to the device, and I'm going to exit the device and clear it completely from memory. First, I'll click the back button. Then I'll click on the list of available tasks, and I'll kill any tasks that are still visible. So now I'm running with a device that's pretty clean. There are no existing activities in memory. Next, I'll go to my app list, and I'll locate Root Catalog and start it up. And I see 4 events that are registered. First, the onCreate event, then onStart, and then onResume. Those are the 3 lifecycle events. And then finally, onCreate Options menu, which is called to generate the menu in the app. Now I'll add code for 2 more lifecycle events, onPause and onStop. I'll add the onPause event. Once again, I'll paste in that code and change the message to match the event name. Then I'll do the same thing for onStop. Once again, be sure to keep the code that's calling the superclasses version of each lifecycle event method. I'll run the app again. When you run the app again from Android Studio, it'll reload the app in the device, so you'll note that you're starting with a fairly fresh state on the device. I'll clear my output, I'll come back to the device, and now I'll click the back button, and I first see the onPause event and then the onStop event. I'll clear my log, and I'll run the app from scratch, and I get onCreate, onStart, and onResume just as I did before. This time, instead of touching the back button, I'll go to the home screen. Once again, I get an onPause and an onStop event. Because this is a virtual device, it's taking a moment to update, but you're seeing the lifecycle events happen. But now, I'll run the app again by going to the app list and clicking it. And this time, I don't get an onCreate event. This is an important distinction in the Android activity lifecycle. If the user touches the back button, that kills the activity completely. There's no trace of it left in memory. And then when they start the app again, the activity has to be created. But if the user touches the home button, that keeps that task intact. And so when the user restarts the app, the activity doesn't have to be recreated, and it'll only have to go through the onStart and onResume events. So this is the value of being able to log events, whether they're lifecycle events, user events such as when the user touches a button, or anything else that's telling you what's going on in the app. Your Java code typically executes in reaction to these events, and knowing how to handle them and execute your own custom Java code is critical to building Android apps. There are certain kinds of events in an Android app that are handled automatically by the application framework, but you can choose to handle yourself with Java code. One of the most common examples is called a configuration event. And one kind of a configuration event is the event that occurs when the user changes the orientation of a device from portrait to landscape or back again. This event is handled automatically by simply destroying the activity in memory and then rebuilding it. Let's take a look at what happens with a basic project where I already have Logcat code in place for the major lifecycle events. This project is named Config Events. I'll run the app on my virtual device. The device starts off in portrait mode. Now in the background, I'm going to expand the size of my Logcat window so I can see all of the output, and I'll clear the window. Then I'll come back to the device and I'll press Ctrl F11 to rotate the device 90 degrees. And here's what happens. The activity goes through an entire life cycle, going through on pause, on stop, on create, on start, on resume, and on create options menu. But here's something very interesting. I'm going to click into one of the edit text controls, and I'll type my name, and then I'll press Ctrl F11 again, and that changes back to portrait. And notice that even though the activity is being recreated from scratch, the value that I typed is still there. The app framework handles a certain amount of holding on to the state of the activity, even though the activity is going through a complete life cycle. But there are times when you want to handle this yourself, and you'll need to do two things. First, you'll need to tell the app that you want to handle the events, and then you'll need to add the Java code. So I'm going to exit the app just by clicking on the back button on the device, and I'll come back to Android Studio, and I'll shrink down my Logcat window. Next, I'll go to my application manifest. By default, each activity handles configuration changes automatically, but you override that by adding attributes to the activity declaration in the manifest file. I'm going to start typing config, and I see an attribute named config changes. And that brings up a list of all the different kinds of configuration changes that I can explicitly handle. There's orientation, the one I'm interested in, one called screen size, and others called font scale, keyboard, keyboard hidden, and so on. It's worth investigating all of these. You never know when you have to handle one of these events yourself. I'm interested in handling the orientation change. But it's not enough just to register that. In the most recent versions of Android, when the device changes orientation, its screen size changes too, and you have to register to handle both of those events. So I'll add a pipe character after the word orientation, then press Control Space, and also choose screen size. So I'm saying I'm handling both of those events. Now I'll go to my main activity class, and I'll add some more code. I'll add this right after the onCreate event. I'll start typing onConfig, and I'll choose the method onConfigurationChanged. When this method is called, you get an object, an instance of a class called configuration. And this object has properties that will tell you all sorts of things about what changed. The object has a property named orientation, but that property is a numeric value. To translate it, you can use a constant of the configuration class. So here's an example. I'll use an if statement here, and I'll say if new config.orientation, and I'll ask if it matches the value of a constant, configuration.orientation_portrait. I'll add a code block for the if statement, and then I'll use a little bit of Logcat output. With log.d, I'll use my log tag constant as the tag, and then a string of changed to portrait. Then I'll add an else clause, and I'll copy and paste this call to the log class, and I'll change this message to changed to landscape. And now I'm ready to test again. I'll run the app in my virtual device again. When the app first comes up, the initial lifecycle events will be logged. I'll see onCreate, and so on. I'll clear my Logcat output in Android Studio and switch back to the device, and then once again rotate it with Ctrl F11 on the keyboard. And then I'll move it out of the way, and I'll see that my lifecycle events are no longer happening, but I am getting the event onConfigurationChanged, and I'm accurately indicating that I've changed to landscape. And then I'll rotate it again with Control F11, and I see changed to portrait. So to handle these configuration changes, you have to register to listen for the event in the application manifest and add the Java code to handle the event.